paraboloid. So this is it's my favorite surface. Hyperbolic paraboloid. It's my favorite one. It's excellent. It's really cool because at the origin, it's like this nice saddle point. It's concave up and concave down. It's actually concave up and concave down at all the points on it, because if you take a cross section one way and then make it parallel to one axis and then the other set of axes, x, y, and then it's really cool. It's really cool. So
you're talking about that you do an animation of?
no, this is not the animation one, but that's two cylinders intersecting and then fading away what they don't intersect at. That's a little different. That's my favorite three-dimensional shape. This is my favorite surface. So what does this look like? If you look at this from above, can everybody see the shape when it's, I mean, I don't have it here. Let me see if I can pull it. Actual contour lines themselves are going to be really symmetrical, but the difference is it's going to go up this way and it's going to go down the other way. The key is you have to label the contours. You have to label the contours. So how do you do that? How do you do that if you wanted to actually come up with that? If you didn't, for number 4, it doesn't give you an equation. It doesn't give you an equation, so you have to actually look at it and make the slices yourselves. The idea, though, is since you don't have any sort of scale to that, you might want to do something like, here's this one, which is this, it's going to be at the same height as that one. Like pair them up in such a way. Does that kind of make sense? Does anybody remember what the equation is for hyperbolic paraboloid? Does anybody remember? To recognize is you're going to get these nice parabolas. Parabolas.
Like if you had x squared minus 1.
What's the cool pattern? I don't know. It's kind of neat here. It goes up by 1. 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 It goes up by. Are there different ways to recognize it? Sure, I'm sure there are. The idea is it's going to go up by 1. It kind of looks like that. It's kind of cool. Using a formula, check that the pattern holds for all x greater than 1 and y greater than 1. How would you do that? Or are you asked there? XZ plane. So actually, can you shade this actually kind of nicely? Yeah, you can. So what's this plane going to look like? I'll use red here. It's going to look like this. There's our plane, right? That's the plane, and it extends. It keeps going through, right? That's part of it. So what's the equation? What's the equation for a plane? Izzy, what is it?
Z equals...
Z minus, well, close. Z minus...
Oh, yeah, Z minus Z.
Oh, it depends. Okay, so you finish yours. I'm sorry, I cut you off. Yes, go ahead.
I was going to say Z equals C plus MX plus NY.
C plus MX plus what?
NY.
Plus NY, like that?
Yeah?
Is that it? Is that what?
I
Okay,
tried it.
that's fine. Let's write down both and do both ways. That's fine. What's the other equation you could use?
Z naught, or Z minus...
Z minus Z naught is equal to what?
N minus
X naught plus N times Y minus Y naught. The key, though, is you have to find M and N in both cases, right? The key is you have to find M and N. Again, let's write this out just so you can really hard code this in. What is M? What is N? Partial Z, partial X, and what's this one? Z, partial Y. So this is when Y is fixed, and this is when X is fixed. So if you're looking at this right here, let's say you were sitting on this plane right here. Let's say you were sitting right here, and you walked along this right here. Are you fixing X or Y?
X. I mean Y.
If you were walking on that, you would be fixing Y, right? You'd be fixing Y. Everybody with me so far? And if you fix Y, what do you know about the change in your height? What happens? Do you go up or down? If you took a walk on the blue line, would you be going up or down?
No.
You wouldn't be going up or down. No. No. I like that. No, it was clear. I got it. You wouldn't be going up or down. That is correct. So what does that tell us? dz dx or dz dy?
ZDX.
What is dz dx going to be? Is it going to be 0? Who agrees with that? Good. Excellent. Hey, we got some popular kids here. Okay, so let's take a look at this. Let's say I was sitting at this point right here, and I wanted to fix the x value. If I fix the x value, I'd be walking straight like this, right?
Yeah.
Am I going to be going up or down?
Down.
Down. And what's the slope?
-2.
-2, because you're at 0, 0, 2 right here. What are you at right here? 0, 1, 0, right? So you're going to go down 2 for every one you go over on that in that case. So that means that the dz dy is going to be equal to what? -2. So what do we have here? We have z minus z naught is equal to 0 times x minus x naught minus 2 times y minus y naught. What's the only other thing we need to plug in at this point?
Point.
Any point we want, right? How about what point do I like, do you think? I like 0, 0, 2 personally. Either way, you're like, come on, there's 2 zeros in the other one too. I like 0, 0, 2. So what do you end up with? Z minus 2 is equal to negative 2 times y minus what? 0. So end up with z minus 2 is equal to negative 2y. You could write it like that, or you could make it z is equal to negative 2y plus 2 if you wanted to. Does that work? It should work because what is not in that equation right there? What's not in there?
X.
X. So independent of x, should you get the same shape?
Yep.
Like if you were to slice this at every x value, like x equals 1, x equals 2, x equals 3, are you going to get the same cross-section? Yes. You should get the same cross-sections, independent of x. Yes.